Hello, my name is Abeba Birhane, and welcome to the presentation of our paper, The Values Encoded in Machine Learning Research. As many of us know, over the last decade, machine learning research has risen from a relatively obscure field to become a global influential one. Machine learning research is deployed in uncountable contexts around the world. And this global influence makes it necessary and urgent to ask the questions that are at the heart of our study, such as what specifically is machine learning research prioritizing and working towards? To put it in another way, what are the values encoded in machine learning research? Before we delve into our methods and findings, it's useful to go a little deeper and contextualize who needs this study and why. So current discussions around machine learning within machine learning communities frequently follow a kind of a historical line of thinking which frames technology as neutral. And these communities often assert that there is no specific values that are encoded. And ironically, this claim of neutrality is often used as a shelter from critics and is seen as a permission to emphasize the benefits of AI. In other fields, such as critical studies, it's obvious that machine learning research enforces particular values. After all, machine learning research is influenced by social factors, and these factors include the personal preferences of scientists, the interests of academic institutions, funding agencies, and companies, and even larger systemic pressures, including systems of oppression. Unfortunately, these critics are often dismissed as kind of outside the purview of machine learning research. Our study directly investigates the most prestigious machine learning research papers at the most prestigious conferences. We chose to focus on highly cited papers because these papers reflect and shape the values of the discipline as a whole. And these papers were drawn from NeurIPS and ICML because these two conferences are most prestigious and the two of the long-running machine learning conferences. Acceptance rates or acceptance to these conferences is a valuable commodity that is often used to evaluate researchers, and submitted papers are typically explicitly written so as to win the approval of the community, particularly the reviewers who are drawn from the same community. Therefore, these papers effectively reveal the values that authors believe are the most valued by that community. We annotated key features of the papers which reveal their values. One, their justification for their choice of project. Two, which attributes of their project they uplift. And three, their considerations of potential negative consequences. We also annotated their institutional affiliation and funding resources. And we also provide an open source fine-grained annotation scheme, which can be used to study other similar documents or such as research papers. We applied our scheme to annotate these 100 most influential machine learning papers, and that adds up to over 3,500 sentences, and we extract their value commitments. First, we examined the chain of reasoning by which a paper justifies its contribution, which we call the justifactory chain. This refers to the extent to which a paper used technical or societal problems to justify or motivate their contributions. Similarly, we categorized the extent to which the paper included a discussion of potential negative impact or not. And as you can see, most papers only justify how they achieve their internal technical goals. So from as you can see, 85% of the papers that we annotated do not justify how they connect their research to societal needs or motivations. And only 4% of those papers make a rigorous attempt to present links connecting their research to societal needs. And papers typically motivate their projects by appealing to the needs of the machine learning community itself. And they rarely mention any potential societal benefits. And even when societal needs are mentioned as part of the justification of the project, these connections are very loose and they are only discussed at the beginning of the paper and no longer. And of the 100 papers that we looked at, only one included a discussion of the negative impacts, and a second one mentioned it in passing, any negative impacts. And 98% of the papers contained no references to potential negative impacts at all. And this lack of discussion of potential harms is especially striking for papers which deal with really contentious application areas such as surveillance, misinformation, or deepfakes. And among the papers that do mention negative potential, the discussion were mostly abstract and hypothetical, rather than being grounded in concrete negative potential of their specific contributions. So we use a conceptualization of value where a value of an entity is a property that's considered desirable for that kind of entity. For example, performance is regarded as a desirable attribute for machine learning research. So we used a hybrid inductive deductive content analysis method. We read sentence by sentence, line by line, from the sections of the abstract, introduction, discussion, and conclusion of each paper. And we deductively annotated any and all values that are uplifted by the sentence. So, for example, from this sentence, we would uplift performance as a value. And in this next one, as you can see, the value that we annotated would be, there's another example, we annotated the values of novelty, simplicity, and fast. So ultimately, we identified 59 values that are significant in machine learning research. So we also began with several values of interest based on prior literature. To be more specific, literature from prior literature uplifting 7 ethical principles and 9 user rights by including important ethical values identified by past work. And specifically looking at these, we can confidently assert that their relative absence in this set of papers. And as you can see, the top values are performance, generalization, building on past work, quantitative evidence, efficiency, and novelty. On the other hand, values related to user rights, which are stated in principles, appeared very rarely, if at all. So, for example, none of the papers mentioned, for example, autonomy, justice, or respect for persons. And kind of taking a closer look at performance, for example, emphasizing performance is the most common way by which papers are attempted to communicate their contribution, by showing a specific quantitative improvement over past work, or according to some metric on a new established data set. In 96% of the papers, obtaining better performance than any other state-of-the-art result is seen as noteworthy or even a necessary contribution. However, through our textual analysis, we found that performance values consistently, and with our discussion are operationalized as correctness averaged across individual predictions, giving equal weight to each instance. And the prioritization of performance values is so entrenched in the field that generic terms such as success or progress or improvement are used as just in synonymous with performance and accuracy. And a common way of appraising the merits of one's work is to claim that it generalizes well. So generalization is understood in terms of the dominant value, performance. A model is perceived as generalizing when it achieves good performance on a range of samples or data sets or domains or tasks or applications. However, again, through our textual analysis, we find that only certain data sets or domains or applications are valued as indicators of model generalization. And papers rarely present any evidence that the work will generalize outside the carefully selected data set or domain or application, or even to a more realistic setting, or that it could help directly address societal needs. Furthermore, the belief that generalization is possible assumes a new dataset will be or should be treated similarly to previously seen data. And none of the annotated papers attempt to counteract this quality or acknowledge its presence. And we find that saying a model is efficient typically indicates that the model uses less of some resources. For example, data efficiency, energy efficiency, label efficiency, memory efficiency, or being low cost or fast or having reduced training time. So the definition and operationalization of efficiency encoded key societal priorities, namely which kind of efficiency matters and to what end. So in short, efficiency is commonly referred to indicate the ability to scale up and not to save resources. So 84% of the papers mentioning valuing efficiency, but only 50% of those papers, or only 50% of those value requiring new resources. So when referencing the principles of efficiency, many papers present evidence that efficiency enables scaling up, while none of the papers present evidence that efficiency can facilitate, for example, work by low resource communities, or can lessen resource extraction, for example, less hardware or data harvesting or carbon emission. So finally, we contextualize the values of these papers by analyzing their author affiliation and funding ties. And as you can see, comparing papers written in 2008 and 2009 to those written in 2018 and 2019, we find that ties to corporations nearly doubled to 79% of all the papers that were annotated. And ties to big tech companies multiplied over fivefold to 58%. While ties to universities declined by 81%, putting the presence of corporations nearly on a par with universities. So in the context of an interdisciplinary readership, including machine learning and other STEM disciplines, that kind of foreground quantitative methodology, our research is both a unique contribution, but it also has its own limitations because it centers qualitative methodology. While quantitative analysis typically favors, large random sampling and strict statistical evidence in service of generalization, qualitative analysis typically favors purposive sampling from information-rich context and richly descriptive evidence in search of an in-depth understanding. Given the overwhelming presence of certain values, the high agreement rate among the annotators, and the similarity of observations made by our team, we believe that our research, other researchers following a similar approach to us, would reach similar conclusions. Also, we cannot claim to have identified every relevant value in machine learning. Rather, we present a collection of such values, and by including important ethical values identified by past work, and especially overlooking for these, we can confidently assert that we can confidently assert of their relative absence in this set of papers. And both annotation schemes and resulting repository of over 3,500 annotated sentences is available over on GitHub, and it can be used to do similar as a research. So the overarching contribution, or the final message is that we present this paper in part to make visible the present state of the field and to demonstrate that to demonstrate its contingent nature. And we would like to highlight that things could be otherwise. It could be otherwise. So for individuals, communities, and institutions wading through difficult to pin down values of the field, as well as those striving towards alternative values, it's really advantageous to have a characterization of the way the field is now, the way the field is currently. That's what our paper does here, and this serves as both a confirmation and a map for understanding, shaping, dismantling, or transforming what is, and for articulating and bringing about alternative visions. Thank you for listening.